In this video, we will consider unsigned and signed binary addition. First, we will consider unsigned binary addition. When we add two numbers and if the result is greater than FF in hex or greater than 255 in decimal, then carry flag is set to 1. So, just by checking carry flag, we can conclude the result is greater than 255 or not. If carry flag is set to 1, then we can say that the result is greater than FF. For example, we'll consider two numbers. Let number 1 be 100 and number 2 be 160. When we add these two numbers, we'll get a result of 260 in decimal, and we can say that this result is greater than 255. We'll consider the operation of same thing in binary. The binary equivalent of 100 is 0110 0100, and binary equivalent of 160 is 1010 0000. When we add these two numbers, we will get 0 plus is 0, here is 0, 1 plus 0 is 1, 0, 0, 1 plus 1 is 0, carries 1, 1 plus 1 is 0, carries 1, 1 plus 1 is 0, and carry is 1. Here we have got, this is, if we calculate the magnitude of this is 04 in hex. To get the right answer, we'll go and check carry flag. In this case, the carry flag is set to 1. To get the right answer, we will add carry flag to higher byte, and we'll consider this as the lower byte, and we'll get the right answer. So to get the right answer, we will store 04 in one register. This makes our lower byte, and we'll store carry flag in one more register. This forms our higher byte, and combining these two we'll get 104 in hex, the right answer, which is nothing but 260 in decimal. So this was about unsigned binary addition. Now we will consider addition of signed binary numbers, signed binary addition. When we talk about signed binary addition for 8-bit microcontroller, the result can be as small as -128. This is for 8-bit microcontroller. The result can be as small as -128 and as large as +127. And when we talk about signed binary addition, we will get two different cases of addition. And in that regard, the very first one is addition of unlike signed numbers. When I say unlike signed numbers, that means then one number can be positive and one number can be negative. When we add such numbers, the result can never exceed our range, which is -128 and +127. That means to say the result is always in the range of -128 to +127. And the second one is addition of like signed numbers. When I say addition of like signed numbers, the numbers can be both positive or the numbers can be both negative. We will consider different examples and we will see what happens. First, we will consider addition of unlike signed numbers. As I said, when we add such numbers, the result never exceeds the range of -128 to +127. To illustrate the same, let us consider an example. Let the two numbers be -20 and +30. When we add these two numbers, we will get a result of +10 in decimal. Let us consider the same operation in binary. The binary equivalent of -20 is 1110 1100, and binary equivalent of +30 is 0001 1110. When we add these two numbers, we will get 0 plus 0 is 0, 0 plus 1 is 1, 1 plus 1 is 0, and a carry 1, 1 plus 1 is 0, plus 1 is 1, and we'll get a carry 1, 1 plus 1 is 0, get a carry 1, 1 plus 1 is 0, carry 1, 1 plus 1 is 0, and a carry 1, 1 plus 1 is 0, and we will get a carry 1. Here, carry flag is set to 1. And we have got one more flag here, which is overflow flag. Overflow flag is C7 XORed with C6. C7 is carry out from bit position 7 and C6 is carry out from bit 6. If we see it here, there is a carry out from this position and there is a carry out from this position. So here overflow flag is set to 0. As overflow flag is set to 0, we can say that whatever result we have got is the right one. If we write the equivalent of this in decimal, we will get 10 in decimal, which is the required result. This was about addition of unlike signed numbers. Here we'll consider addition of like signed numbers. When we add such numbers, the result may exceed the range of +127 or it can be within the range of +127. First, we will consider an example in which the result exceeds the range of +127. Let the two numbers be 80 and 90. When we add these two numbers, we will get a result of +170 in decimal. Let us consider the same operation in binary. The binary equivalent of 80 is 0101 0000, and the binary equivalent of 90 is 0101 1010. When we add these two numbers, we will get a result of 0 plus 0 is 0, 0 plus 1 is 1, 0 plus 0 is 0, 0 plus 1 is 1, 1 plus 1 is 0, and a carry 1, 0 plus 0 is 0, plus 1 is 1, 1 plus 1 is 0, and a carry 1, 0 plus 1 is 1. And if we observe, carry flag is set to 0. And if we look at overflow flag, we know that overflow flag is C7 XORed with C6. And here, if we observe it closely, there is a carry out from bit 6. So here is 1 XORed with there is no carry out from bit position 7. So here it is 0. So overflow flag is 0 XORed with 1 is 1. So overflow flag is set to 1. As overflow flag is set to 1, we can say that the result exceeds the range of plus 127. If we leave this signed bit and calculate the magnitude of this, we will get a result of 42 in decimal. So what it tries to convey is the result is exceeding 128 by amount of 42. Here I said 128, not 127, because it starts from 0 to plus 127. So the total positive numbers are 128. So what this is conveying is the result is exceeding 128 by an amount of 42. So if we add 42 with 128, we will get 170 in decimal, which is our answer. So what our program should do is, there is no point of this signed bit. So our program should complement the signed bit and then we'll get the right answer. So here what we can conclude is, whenever overflow flag is set to 1, our program should complement the signed bit. When we complement the signed bit, we will get 0. Here it is complemented the signed bit, and the rest is same, 0 1 0 and 1 0 1 0, and this is 42 in decimal. So what it is saying is the result is exceeding 128 by an amount of 42. So if we add 42 with 128, we'll get the right answer. Again, we will consider two more positive numbers, but in this case, the result doesn't exceed the range of plus 127. So let the two numbers be 50 and 60. When we add these two numbers, we will get a result of 110 in decimal. Let us consider the same operation in binary. The binary equivalent of 50 is 0011 0010, and the binary equivalent of 60 is 0011 1100. When we add these two numbers, we will get 0 plus 0 is 0, 1 plus 0 is 1, 0 plus 1 is 1, 0 plus 1 is 1, 1 plus 1 is 0, and a carry of 1, 1 plus 1 is 0, 0 plus 1 is 1, we'll get a carry 1, 0 plus 1 is 1, and 0 plus 0 is 0. So here carry flag is set to 0. And if we look at the overflow flag is again C7 XORed with C6. And if we observe bit 6, there is no carry out from bit 6 to bit 7. Here it is 0. And XORed with C7, if you observe it here, again there is no carry out from bit position 7. It is 0. So overflow flag is set to 0. As overflow flag is set to 0, we can say that whatever result we have got is the right result. If we calculate the decimal equivalent of this, which is nothing but 110 in decimal, which is the right answer. Here we will consider addition of two negative numbers and the result of which exceeds the negative limit of minus 128. Let the two negative numbers be minus 80 and minus 90. When we add these two numbers, we will get a result of minus 170 in decimal. And here we know that the result exceeds the negative limit of minus 128. Let us consider the same operation in binary. The binary equivalent of minus 80 is 1011 0000, and binary equivalent of minus 90 is 1010 0110. If we add these two numbers, we will get 0 plus 0 is 0, 0 plus 1 is 1, 0 plus 1 is 1, 0 plus 0 is 0, 1 plus 0 is 1, 1 plus 1 is 0, and we will get a carry 1, 0 plus 1 is 1, 1 plus 1 is 0, and a carry 1. So here we can say that carry flag is set to 1, and if we look at the overflow flag, again overflow flag is equal to C7 XORed with C6, and if we observe it closely, there is no carry out from bit position 6, so it is 0 XORed with C7. And if we observe it, the bit position 7, yes, there is a carry out from bit position 7, and it is 1. So overflow flag is set to 1. As overflow flag is set to 1, we can definitely say that the result exceeds the negative limit of minus 128. By what amount? We will calculate it now. We'll consider the magnitude again, which is 0, 1, 0, 1, 0, 1, 1, 0. This is the result. If we calculate the magnitude of this, which is nothing but 86 in decimal, this doesn't seem the right answer. As overflow flag is set to 1, and if we complement this signed bit, we will see what we're going to get. We'll complement the signed bit and we'll get it 1, and we'll keep the remaining answer the same as before, which is 1 0 1 0 1 1 0. We'll get this result, and if we calculate the magnitude of this, which is nothing but minus 32 in decimal. So now we have got the right answer. So what this result is saying is the result exceeds the negative limit of minus 128 by an amount of minus 32. If we add these two numbers, we will get minus 170 as our answer. So what we should do here is, when we add two negative numbers and if the result exceeds the negative limit of minus 128, and we know that overflow flag is going to set to 1, and what our program should do is it should again complement the signed bit. When we complement the signed bit, we are going to get the right result of minus 170. Here we will consider the addition of two more negative numbers, but the sum doesn't exceed the negative limit of minus 128. Let the two negative numbers be minus 50 and minus 60. When we add these two numbers, we will get a result of minus 110 in decimal. And by looking at the result, we can say that the result doesn't exceed the negative limit of minus 128. Let us consider the same operation in binary. The binary equivalent of minus 50 is 1100 1000, and binary equivalent of minus 60 is 1100 0100. When we add these two numbers, we will get 0 plus 0 is 0, 0 plus 0 is 0, 0 plus 1 is 1, 1 plus 0 is 1, 0 plus 0 is 0, 0 plus 0 is 0,
1 plus 1 is 0 and we'll get a carry 1. 1 plus 1 is 0. 0 plus 1 is 1 and we will get a carry 1. So here carry flag is set to 1, and if we look at the overflow flag is C7 XORed with C7 XORed with C6. And if we look at C6, yes, there is a carry out from bit position 6. And if we look at C7 for bit position 7, yes, there is again carry out from bit position 7, which is 1, and 1 XORed with 1 is 0. So overflow flag is set to 0. As overflow flag is set to 0, we can say that the result which we have got is the right result. If we calculate the magnitude of the result, which is nothing but minus 110 in decimal, which is the required result. So we can discard this carry flag, and the result what we have got is the right result.